All right, now I know I said that I loved mixture problems, and I know I said I loved a lot of things, but I really love these problems. These are like awesome problems. Now I know you're thinking this is weird, that I really like this. In fact, my daughter and my sister say it was an accident at birth, but that's beside the point, okay? I actually used to do math problems for fun when I was in high school. Stop laughing. Okay, anyway, let's take a look at this one. Greg and Mark are 21 miles apart and walking towards each other. I know you love these. I know you love these. And they're walking towards each other. How long will it take them to meet if Greg walks 5 miles per hour and Mark walks 2 miles per hour? Now listen. I happen to have Greg and Mark. Here's Greg. Here's Mark. I know we didn't say Mark has a dog, but Mark has a dog. There's Greg and there's Mark. Okay. And they're 21 miles apart. That's what I know. So right now, Greg and Mark are 21 miles apart. Okay, they're 21 miles apart, walking towards each other. How long will it take them to meet if Greg walks 5 miles per hour? So Greg, he's walking 5 miles per hour, and Mark walks 2 miles per hour. Okay, how far have they walked when they meet? Okay, before we do this problem, we have to talk about this. If you remember, there was a problem we did a couple lessons ago about Shireen going, she was driving somewhere, New York to Baltimore, I think, but I'm not really sure. And she was going to go back and forth. And we wanted to do the problem. We very simply just set up D equals RT and divided, and we were done. Well, the difference here is we have two different people, two different rates. It's not going to be as easy. When we have a formula, which we do, distance equals rate times time because we're moving. This is called a motion problem because something's in motion. Okay? When we have two different variables, Greg and Mark, okay, two different rates, okay, or two different whatever, okay, and we have a formula, we're going to use a chart. And to use the chart, this is how the chart's going to look. And this chart will never change. Even when you get to intermediate algebra and the motion problems are different, this chart does not change. Even though your textbook might change the chart, trust me, I would not change the chart. Okay, I'm going to show you how to use this chart. Okay, and I'm going to give you a little bit of helpful hints, which is in your book. Okay, I'm going to go Greg, Mark. Okay, here we go. First thing is exactly what I just said. If there's more than one variable and you have a formula, use a chart, same as the last lesson. Time does not mean clock time. So if it says Greg leaves at 3 o'clock, we do not put 3 o'clock here because time is the time you actually spend on the road, in the sea if you're a boat, wherever you are, in the air if you're a plane. Time is time in motion. If you put 3 o'clock there, that means 3 o'clock hours. That makes no sense, or minutes, or seconds. Okay, time is not clock time. That's really important. That's why it's bolded. Okay, the next one is the units must be consistent. If, oops, I put Greg and Mark in rate. That was not good. Thank you for noticing that. All right, you didn't notice it, I did, but okay, somebody did. I bet you somebody out there did. Okay, at any rate, units must be consistent. So if time is in minutes and rate is in not miles per minute, let's put it in hours. Time is in hours and rate is in miles per hour, then distance is going to be in miles. It's going to have to be consistent. Okay? So Greg, Mark. Okay. The last thing is, in these problems, okay, this is the most important thing. Now listen, I wrote highlight on this little slide to make everybody happy, but the truth of the matter is, I call it squiggle. Here's what I'm going to tell you about the squiggle. Okay, it says highlight on your little slide. You're going to be able to fill in 2 columns from the information you get from the question. The last column you can't fill in, you're going to squiggle. Now, squiggle is so important. Oh, okay, the highlight, whatever you want to call it. The squiggle is so important because it tells you 2 things. It tells you, number 1, to use the formula here for that column, wherever that column is. Okay, and it also tells you that that's what the equation is going to be about. Now, here's the hardest part probably, but it's really just common sense. And the reason people get this wrong is because they don't want to use their common sense. They kind of want to find it in the problem. Sometimes what you're writing the equation about is just common sense. It's not going to be stated in the problem. So let's do this problem. Let's redo this challenge problem and go all the way. So let's see what we got. Greg and Mark are 21 miles apart. They're walking towards each other. Okay? How long will it take them to meet? So we're looking for the time, how long it takes them to meet. If Greg walks 5 miles per hour and Mark walks 2 miles per hour. Now, they say they're walking towards each other. They didn't say they start at different times, which means we have to assume they start at the same time. That means times are equal. Because once Greg and Mark meet, that means they were walking for the same amount of time. Let's think about this. He starts, now look, he's walking faster, so he's going to get further. But he's walking, and then he's walking. Somewhere they're going to meet. Somewhere they meet, okay? When they meet, they stop walking. They both stop. If you both stop, it's got to be that they're on the road the same amount of time. So times have to be equal. You'll know times aren't equal because it'll say somebody started at 10 o'clock, somebody started at 12 o'clock. But right now it says they start walking towards each other. So you know the times are equal, so you put an X in both of them. Now, that leaves me one column. Oh, I'm not allowed to use red, they said, so red's out. Not allowed to use green, green's out. Okay, so here's the deal. One column's left, so I have to squiggle that column. Okay, highlight, whatever makes you happy. I like squiggle. Remember, the squiggle tells me use the formula here. So that means I have to take rate times time, and that's going to equal distance. Rate times time, and that's going to equal distance. Rate times time, and that's going to equal distance. Now listen, some of you are going, well, what happened to that 21 miles? That's distance. You can't put 21 miles here, because if you put 21 miles here, it means Greg walked 21 miles. Did Mark do nothing? You can't do that. So that doesn't go in the chart. But now I squiggled, and remember the squiggle tells me I'm writing the equation about distance. Well, you got to say, what do I know about distance? Well, here's what I know about distance. Look what just happened. Even though Greg walked further and then Mark walked, they met here, they covered together that whole 21 miles. That's what I know about distance. So I know the distance that Greg walked plus the distance that Mark walked equal the total distance, which is 21. What told me to think about that was the fact that I squiggled distance. It means I need to write my equation about distance. So here's how I write my equation. The distance Greg walked is 5x. The distance Mark walked is 2x. And that equals 21. So this is 7x equals 21. That's so cool. Come on. Come on, you know it's cool. You know you're holding back. Okay, we divide by 7 and we get x equals 3. What does the 3 represent? Time. Time is in hours. How did I know that? Because this is miles per hour. Okay, so 3 hours. Now we have to make sure you can't stop there. You have to make sure you answer the question. Here's the question. How far, 5 miles per hour, 2 miles per hour? No, I think there's more. There's 2 questions here. Okay, how long will it take them to meet? Okay, well, that's the first question. It's going to take them 3 hours to meet. So we're done with the first part of the question. Here's the second part of the question. Second part of the question says, how far have they walked when they meet? Okay, well, so we want the distance for Greg and the distance for Mark. We already know, we already said, Greg's walking faster, so he's going to walk further. That's okay. So let's do distance, and let's do Greg. Greg's distance is 5 times x, or 5, let me write 5 times x so you know where that came from. 5 times x, or 5 times 3, which is 15. What's it in? It's in miles, because remember this is miles per hour, so distance is in miles. Okay, and how far did Mark walk? Mark walked 2x, which is 2 times 3, which is 6 miles. And notice together they walked, yes, 21 miles. Now we're done. So once you get the answer, don't think, well, that's it, I'm done. You have to make sure it meets all the needs of your question. And that's it. That's so cool. Here's the key to this problem. The key is the squiggle. The key is also this silly little diagram that puts all this miles stuff together, because you know what's going on. They're walking towards each other. So, but the key, the real key, but you know, all of this is important, but the key to me is the squiggle, because the squiggle says use the formula, and the squiggle says that's what I set up the equation about. The biggest mistake people make is they want to fill in this whole chart by the information in the question. That is not the way to do these problems. This is a great problem. We're going to do some more. All right. Here's my Brenda and Carol. Here, we're all set up here. Okay, so here we go. Rate times times, the next problem in your workbook, equals distance. I'll read the problem, but I already know they're driving, so I know it's a motion problem, so I know we have this formula. Motion problem, driving, this formula. Okay, here we go. We got Brenda and we have Carol. I know these are incredibly straight lines. Okay, here's what we got. Brenda and Carol are sisters. They're leaving New York, driving in opposite directions. Okay, so we got that kind of set up. Okay, I like the little diagram because it helps me with the formula at the end. That's my opinion. Okay, Brenda drives at the rate of 65 miles per hour. That's for Brenda. And Carol at the rate of 50 miles per hour. Okay, then it says Carol leaves at 10 a.m., Brenda leaves at 11. Here's the deal. They leave at different times. They can't both be X. Okay, now here's what I know. I know that Carol is on the road for an hour longer. How do I know that? She left earlier. Because you want to know when they're 855 miles apart. So they're going to drive, and in the end, this total has got to be 855 miles. That's what you know. The total driven by both cars together is 855 miles. That's what you know. She goes this way, she goes that way, and in total they're going 855 miles. Of course, one may drive longer than the other on the road. We know that's true. And one may drive further than the other. However, we know that Carol is on the road 1 hour longer than Brenda. Now, could you have said, Brenda is driving 1 hour less? Yes. Then you could have made this X minus 1. You could have made this X. It doesn't matter who you make X. Okay? But make sure the other one accommodates for that. But we know Carol left earlier. So Carol's on the road an hour longer, right? If I leave at 10 and you leave at 11 and we meet at noon, I have driven longer, okay? So I'm on the road longer. So we squiggle. Be very careful about doing this. This is one more, so this gets the X plus 1. Be very careful about giving Brenda the X plus 1. Because just because it's 11 o'clock, we're not adding 1 to this. What we're saying is, I left at 10. I left earlier. I'm on the road longer. Okay, think about that. We have this guy left. We're squiggling. 65X. And this is 50 times the quantity, X plus 1. Remember, the squiggle tells me use the formula here. The squiggle also tells me I'm going to say something about distance in my equation. And I am. I know Carol and Brenda together is 855 miles, okay? Because you're going, I'm going, together we're going to travel that whole distance. So the distance that Brenda drove plus the distance that Carol drove is 855. Now, you don't always add the distances together. It just depends what the problem is about, okay? So don't just assume it's that. So Brenda is 65X plus the distance for Carol is 50 times the quantity X plus 1 equals 855. Ready? Here we go. 65X plus distribute 50X plus 50. I love these problems. They're so cool. 65 plus 50 is 115X plus 50 equals 855. Subtract 50. You get 115X equals 805. And if this is good, we can, maybe this goes in evenly. I'm not sure. Let's multiply 115 times 7. Oh, thank gosh. Divide by 115. We do get 7. X equals 7. What does X represent? The time we're on the road. So it's 7 hours. Now, let's think about what the question says. How long will Brenda drive before they are? Okay, you want to know how long Brenda drives. How long Brenda drives is just X, which is 7 hours. If you wanted how long Carol drives, that's X plus 1 or 8 hours. Okay, but you only wanted Brenda, so you are done. Brenda drives 7 hours. And that's it. That's the whole question for that one. Okay, of course, I could find a distance that Brenda drives by plugging in the X here. I could find a distance that Carol drives by plugging in the X here. And then together, guess what they would add up to? Yes, that 855. That would be so cool. But that's all you needed to do that problem. 7 hours for Brenda. It's a long drive. Okay, we're going to do another problem. All right, you're almost on your own here. I'm just going to help you for a second. A person drives from town A to town B. Okay, I'm going to draw this one. We're going from town A to town B. Okay, you're driving from town A to town B at 65 miles an hour. 50 miles per hour, sorry. I guess I didn't want to drive that slow. Okay, so first they're driving, and then they fly back from same place now, okay? B to A, okay, they're flying back, and they're flying at the rate of 160 miles, a little faster, 160 miles per hour. If the total traveling time is 21 hours, how far is it from town A to town B? Okay, that's what we're asking you to do. Now, I'm going to help you out a little. What you got here is you got driving. This is what's different. This is the two different things, because there's different rates here. And you got flying. So I'm going to ask you to go to your workbook, stop the video, and fill in just the chart. All right, here we go. A person drives from town A to, so he's driving at 50 and flying back at 160. Do we know anything about time? Let's see. A person drives from town A to Mammoth, the rate of 50 minutes, then flies in the rate of 160 miles per hour. If the total traveling time is 21 hours, this is a little hard. Okay, if the total traveling time is 21 hours, how far is it from town A to town B? Let's talk about that. I know that these two have to add up to 21 because the total traveling time is 21 hours. I don't know anything about the, there's actually a couple ways we can solve this problem. Let's look at it two different ways. Some of you might think, well, you know what we could do with this? We could make these both x. How come those could both be x? Let's talk about this. There's actually two ways to do this problem. We're going to do them both ways. Not only can we assume the distances are the same because we're assuming they're taking the same route, but we have to, otherwise we can't solve this problem at all, okay? So at any rate, we can assume that the distances are the same, which tells me now that I have to squiggle time. Okay, if I squiggle time now, that changes this a little bit, but it makes it a cooler problem. I'll show you why it makes it a cooler problem. Because this says we have to now use our formula here. Well, remember our formula is rate times time equals distance, but now we're solving for time. If we're solving for time, we know how to do this, literal equations. Okay, if we're solving for time, we divide by rate, and we get time is distance over rate. So we can take distance and put it right over rate. Distance and put it, oh, come on, tell me that's not too cool. Okay, we can do that. Okay, now, here's the deal. It says that the total traveling time is 21 hours. If the total traveling time is 21 hours, that means that the time it takes you to drive plus the time it takes you to fly is 21. Does that make sense, right? Total time, 21 hours. So again, the squiggle told me to use the formula, which I did. The squiggle says I have to write the equation about that column. Okay, so I have total time for driving, which is x over 50, plus the total time for flying is x over 160, which equals 21. Now this is going to be interesting because now I need a common denominator for 160 and 50. Oh, that's going to be fun. Okay, I'm going to take multiples of 160. 160, 320, 480, not yet, huh? 5, 160, it's actually going to be 6. This is going to be a bear. A 160 is going to give me 0, 8, 14, 640, not yet, another 120, there it is. Here, no, 160, sorry, another 160, multiples of 160 is 800. This goes into 800, this goes into 800. Oh, that was fun. Okay, a little hard, but that was fun. We could do it. So 800 is the LCD. LCD is 800. Wow. It's okay. Math doesn't always have to be neat. It's okay. We're going to do this another way. If you don't like this problem, it's okay. It's all good. Okay. 50 into 800. That goes 16 times. 160 into 800, what's that, 5 times? I think I did that 5 times. 30, yep, 5 times. Okay, so we have 16x plus, oh, this is a bear problem, and that's 21 times 800. 21 times 800. I wish I had a calculator. That's 16,800. But watch what happens now. This is going to be so cool. Watch. So cool. Watch. 16x plus 5x is 21x equals 16,800. Divide by 21. We already know what this answer is. Why do we know what this answer is? Because we just did 800 times 21 is that. So that answer must be 800. So x is 800. What is 800? It's the distance. So it's the miles. 800 miles. That's what x is. I don't know if that's the answer. It is the answer because the question is, how far is it from town A to town B? And it is 800 miles. Awesome. That was awesome, wasn't it? That was hard, but it was awesome. It was hard because of the silly big numbers. But I have to tell you what's really cool. We can do this problem another way, and I'm going to do it another way. Okay, so remember 800's the answer. Okay, in fact, I'm going to put that right here for me. 800's the answer. But I'm going to do this problem another way. All right, driving, flying. Driving is 50. Flying is 160. Now, let's say we don't put the x's here. Let's say we know that the time, okay, the total time is 21 hours. Watch this. Let's just think about this for a second. I can't make this 21 because it's the total time. It's not just the driving time. Can't make this 21 for the same reason. But here's what I can do. Think about if this makes sense. If I make one of them x, because I don't know, in fact, let me make, and there is a reason, it doesn't matter which one I make x, but I want to make this one x because I know in the end it'll be easy to multiply. Okay, doesn't matter, but I can make either one x. If I make that x, that means that I had 21 hours in total, but I used up x of it. So I need to know how many hours I have left. Now remember, x is not a number right now, it's just x. So if I had x hours that I used up, I had 21 hours. Think about having, here I have 21 hours in my pocket. I used up x hours. Think about this. Watch. I have 20, these are my hours. I have 21 hours in my pocket. I use up x of them. How much do I have left in my pocket? 21 minus what I just used up. I can prove that to you. I can prove that to you. If x is 6, what's 21 minus 6? That would be 15. And 15 plus 6 is 21. Okay, so it's the total minus what you used up, right? Think about that. I had 21 and used up x. So I have 21 minus x. Okay? Now, that leaves this as the squiggle. Right? Rate times time is distance. Okay. So, now I need my equation to be written by distance. Well, what do I know about my distance? Well, I know, remember what happened, because I almost forgot already. I leave town A, go to town B, but take the same route, that's what we had to assume, take the same route back. So what do I know about distances? I know my distances are equal. So here's what I have. I know the distance I flew equals the distance I drove. So that's 160x equals 50 times 21 minus x, sorry, minus x. Ready? Watch, watch. 160x equals 50 times 21. 50 times 21. I know what that is. 1050 minus 50x. Now, here we go. I'm not done. I'm not done. Add 50x. I get 210x. You having fun yet? Okay. Equals 1050. Divide by 210. Divide by 210. I'm thinking that's 5. You thinking that's 5 with me? I'm thinking that's 5. That is clearly 5. X equals 5. But we didn't get 5. We had 800. We know the answer is 800. Why is the answer 800? Well, here's why. What does 5 represent? 5 represents the hours that you flew. This is 5 hours. We don't want hours, we want distance, remember. Distance. Well, we want distance, what can we do? Well, we could plug it into here or to here. Why doesn't it matter? It doesn't matter because these are equal. I'm going to plug it into this because it looks easy. 160 times 5 is, guess what? 800 miles. So it doesn't matter if you do it this way or the way we did before, but you got to do it one of the ways. Either way, we had to know the distances were equal. That's a great problem because it all depends what you were thinking when you were doing it. Because if you thought, well, the distances are equal, I can call them both x, you can do that. And then you had to solve that literally for time. whatever way you want to do it, it will work out. Just follow the steps. Awesome problem. My favorite problem. That's my favorite one so far. All right, I know you'd be upset. I knew you'd be upset if we were done, so we're not done yet. Here we go. Rosie started her trip driving at 70 miles per hour. So that's her rate. Okay, but then it started to snow. So she slowed her speed down to 40 miles per hour. Okay? So this is, I don't know what you want to call this. Rate 1, maybe. I don't know what name. You know, snow. I don't know. It doesn't matter. Okay. If she drove a total of 330 miles, that's what she drove. So she's just driving to someplace, and then she slows down, and she goes to, that's all she's doing. She's just driving. And she drives a total of 330 miles. The only thing that changes on this trip is that her rate changes. That's why we need a box. That's why we still need a chart, because there are different rates. Okay? All right. How long did the entire trip take if she drove the same amount of time at each rate of speed? So they're telling you that. They're telling you she drove the same amount of time. So this is X, and this is X. Squiggle. How do I know I squiggle? I'm squiggling because there's one column left. That's how I know I'm squiggling. Now you have to use the formula. Rate times time equals distance. Rate times time is 70x. Rate times time is 40x. Now, not only does that squiggle remember to tell me to use the formula, it also says I have to write my equation about distance. So what do I know about distance? Well, I know she went a total of 330 miles. So the distance of 1 plus, the distance of 1 plus the distance of 2, that's right, equals 330, total distance. That's 70x plus 40x. Oh, this one's so easy. This is 110x equals 330. Divide by 110. I can do that one in my head. 3 what? 3 hours. Does that answer the question? I don't know. It says, how long did the entire trip take? Now, be careful. Be careful. You want the entire trip. Are you done? No. You're not done, because X is 3 hours is how much she drove at this rate, but then it snowed and she drove for another 3 hours. So the entire trip, be careful. Didn't you know that was too easy? You had to know that. So it's 3 plus 3, or 6 hours. That's the entire trip. Be very, very careful. Okay? And that's it. That was a great problem. Okay, we've had a plane, we've had cars, no bicycles, but there may be some in the homework problems, but now we have buses. Okay, 2 buses leave from the same place at the same time. One bus travels north, the other south. I know this isn't north and south, but it took up too much space on the board to go up and down. So this is what we got, okay? One bus travels north and the other travels south at a speed that is 10 miles per hour faster. Okay, in 3 hours, the buses are 360 miles apart. Okay, so this is what I know. I know we're going, and one bus is definitely going to go further than the other, but in the end, we're going to be 360 miles apart. Okay, that's what I know. I also know that one bus was 10 miles per hour faster than another bus. That gives me something about their rate. Okay, that means somebody's got to be X, but then the other one is X plus 10, because that's the bus that's 10 miles per hour faster. Miles per hour is the rate. Okay, so that's what I know. I also know that it says that in 3 hours, so they're on the road for 3 hours. That's what else I know. They give me that. Squiggle. How do I know I squiggle? Because there's one column left. Now I multiply rate times time, 3x, rate times time, 3 times the quantity, x plus 10. Now this tells me to squiggle that I need to write the equation in terms of distance. Well, I know together they went 360 miles. So again, the distance of one of the buses plus the distance of the other bus equals 360. So one of the buses' distance is 3x. That's the distance of bus 1. The distance of bus 2 is 3 times the quantity, x plus 10. Together, it's 360. All right, we can do this. This is cake. 3x plus 30, because we had to distribute. And that equals 360. This is 6x plus 30 equals 360. Subtract 30. Subtract 30. 6x equals 330. Divide by 6. Oh, this is not going to go in nicely, is it? Okay. X equals 5, 30, remainder of 3. Oh, yes, it does. Okay, sorry. 55 miles per. Is it miles per hour? No, it's not. See, I goofed. X is what? Oh, yeah, it is miles per hour. Bus 1, miles per hour, X, miles per hour. By the way, I should have figured out that this was divisible. 330 was divisible by 6 because remember it's divisible by 2 because the last digit was even. It's also divisible by 3 because if I add the digits, it's 6, and so it's divisible by 3 and 2, so it must be divisible by 6. So bus 1 is going 55 miles per hour. Let's see what it says. In 3 hours, the buses are. Find the speed of each bus. Okay, good. I have the speed of bus 1. Bus 1 is 55 miles per hour. Bus 2 is X plus 10, or 55 plus 10, 65 miles per hour. So that's the speed of each bus. I picked these problems on purpose because they're each a little different. The one I went over 2 ways. I wanted to show you that if you have another idea, it's fine. It's not always done one way, but the chart and the squiggle is the key. All right? So that's it for motion problems.